Okay, hello, my dear viewers. Today we are going to be looking at some, maybe calculation on Boyle's Law. Calculation on Boyle's Law. Now, before we go to the calculation on Boyle's Law, remember in our previous video, I said volume is inversely proportional to pressure. Then from there, we have V equals to what? K over P, where K is the constant of proportionality. When we cross multiply, P times V is PV equals to K. So that will give us P1 V1 equals to P2 V2. It can still be equals to P3 V3. So this one shows that the product of pressure and volume will always be a constant value. Yes, provided temperature is being kept constant. Then we will now realize that, yes, in physics, when the product of what? Pressure and volume will always give us work done. So work done is equals to P delta V, where delta V means change in volume. So where delta V, change in volume, can be what? V2 minus V1. That's if and only if V2 is greater than V1. V2 will be greater than V1 because volume is a scalar quantity. So we don't expect having a negative value. So whenever we're being asked to look for work done by a gas, we are going to be using P into delta V can be V2 minus V1, or we can still use V1 minus V2, provided V1 is greater than V2. So let's now maybe look at some examples. For example, let's assume, I have a question like this, that 50 cm cube of a fixed mass of gas exerts a pressure of 200 Newton per meter square. Calculate the volume. Calculate the volume that is occupied. Calculate the volume that is occupied when the pressure is halved. Yes. Now, whenever I want to solve questions that involve calculations, yes, it's advisable for us to bring out the parameters. Gas laws, we see them in chemistry, in physics. But in physics, we mostly talk about Boyle's law, Charles' law, pressure law, and general gas law. Now, we'll bring out the parameters. 50 cm cube of a fixed mass of gas, that means V1, that's the initial volume, is 50 cm cube. Yes, exerts a pressure of 200 Newton per meter square. So our P1 is 200 Newton per meter square. Calculate the volume, that's the final volume, V2. Calculate the volume that is occupied when the pressure is halved. When the pressure is half. So the pressure is half. Here is 200. Half of 200 is going to give us 100 Newton per meter square. Now we have the formula. We have the formula as P1 V1 equals to P2 V2. Somebody may decide to say, no, I don't want to use it this way. The person wants to use it as P2 V2 equals to what? P1 V1. No problem. It's even better because what you are looking for is V2, and V2 is that we'll just make V2 the subject of the formula. If you don't want to make V2 the subject of the formula, in the place of P2, I will replace 100 multiplied by V2. P1 is 200 multiplied by V1. V1 is 50. So I'm looking for V2. What is stopping V2 is 100, and 100 is multiplying it. And the opposite of multiplication is division. Yes. So what you divide on the left hand side, also use it on the right hand side. So here, we divide by 100, and here we divide by 100. So let me take it up this way. So 100 cancels 100. I'm left with V2. Here, these two zeros will cancel these two zeros. 50 times 2 will be 100 cm cube. And there's not something we notice here. When the we notice that when the pressure is halved, because here is 200, but here is 100. When the pressure is halved, instead the volume is doubled. And that's what we notice in any form of inverse relationship. Yes, once the pressure is halved, the volume will be doubled. If the volume is doubled, the pressure will be half. If the volume is being multiplied by 3, then the pressure will instead be divided by 3. That's what the inverse relationship is all about. Thanks for watching my video. Do make sure you like, you subscribe, and share. Bye.